Welcome to stream number 44 in this series where we are programming an NES game live from scratch on Twitch. Let's get started. Last time we did a quick stream last Wednesday and I rewrote the level loading code so that it didn't use the attribute information anymore. It is now just basically taking the entire level file in the asset tool, writing it out in one large buffer, and then that's it. It's closing the map file. And so we rewrote the code to handle that so that now it's just simply loading that straight up, right? So that's what we did last time. Got that done in about 45 minutes, and then we were looking at the attribute code and how to handle the palettes, and seemed like there was maybe some more work to be done. I had incorrectly stated that we weren't using these palette values that are written to the beginning of the map, but that's actually not totally true. We are doing that. I had forgotten. So in the load level code here, we are loading the palettes. We are incrementing one by one through the palette values that are written out here in the beginning of the map. Oh, you know, we don't need this right now. This was the work from last week that I didn't really get to. So we're writing out our palette values here, and then in this situation what we're doing is we are taking the palette value, putting in param 1, taking the value of y, putting in param 2, and the reason is because the load palette value, the load palette procedure will actually load the palette values into the PPU based on these parameters. So the first parameter is the palette value, the second parameter is the destination palette. So that part where we were hard coding the palette right here, that was just for the title screen. I forgot that we had done that just for the title screen. So we are properly loading the palettes that we are writing here, and then basically what we're doing in here is we're going through and we're looking for 4 palettes that are used by the meta tiles and putting it into the palette lookup table. The reason we're doing that for the palette lookup table is we are saying, okay, if we have it already, we don't need to restore that in the map palette array that we eventually write out the 4 bytes for. So that's all that is. It's really just a way of identifying the fact that we've already written, or we're already going to write that palette index to the file. So now that we have that, and that's working kind of as we need it to, assuming that we're not going to support more than 4 palettes to start off with, we might decide we want to do more. I had originally said we would need to potentially remap the meta tiles to all map directly within 0 through 3 in order to make the attributes work properly, but that's actually not true. I think the only thing we need to do now is we need to write something that maps the meta tile value to the palette value, which we can do because we're already looking at that here when we gather this map palette information. So basically what I'm saying is that as we traverse our map, why does it keep doing this? I'd love to know. It's weird. So as we traverse our map line by line, we're looking at each of these meta tile values, and we're looking at the palette that it's using, right? We've got a set of palettes, and then we have our 4 palettes here that we write. The other thing we need to be able to do, because we're not storing the attribute value anymore, in line with the map data, is we need to be able to say, okay, we have metatile 5 here, and it corresponds to this palette entry, I guess, or something to that effect. I mean, it could be as, I mean, there's, I'm trying to think of what the right way to do this would be. We don't want it to just be, obviously, an array, a big array of up to 255 values, because we'd waste bytes that way. We could look it up by having another 4 bytes that say, okay, this is metatile 5, this is metatile 3, this is metatile 17, this is metatile 8, whatever the metatile value is, and then we look it up, and then whatever the index is, that's going to be our palette value that we use in the attribute buffer that we're using for updating the attribute table. That seems like the best approach, because then at worst case we're still, you know, a constant for lookup. It's not we're not wasting the memory versus, you know, so we're doing a little bit of extra computational work for every metatile we load versus the wasted memory. I'm trying to think if there's another way that we could do that. I mean, the only other way that we could do that is we remap all the tiles to 0 through 3, and then whatever the metatile value is, we could do that. That would be technically more efficient, make the asset tool reprocess everything. So what we would do is we would have a table that says, okay, if you get metatile map value 0, it's really 5. This is really 3. This is 17. This is really 8. The palette value, then this palette lookup index becomes irrelevant. And it's does it work out to be the same thing? It actually works out to be the same thing. And then let me think about that. We're essentially doing that anyway when we when we figure out what the palette values are. Maybe we do want to do that. And then we know, then that's a constant lookup into the 4 possible values. Now if that changes where we're going to have more, that's okay, because it's still a constant lookup into that array. I think I'm okay with that. We'll probably load that into memory. Just have 4 bytes or however many bytes we want to support. So let's do this. Let's how did you do this? You say, oh, so max metatiles, let's say equals 4. Right, so we're just saying that's how many metatiles we can have, and then we're going to say, we'll just put it right here, metatile table can you just do, I wonder if you can just do res max metatiles. Yeah, okay. So that'll reserve an array that's the appropriate size. And so what we'll do is we'll say, so we'll read the first byte, which is our rows, then we read 4 bytes to load the palettes, and then we read 4 bytes that tells us the mapping of the local metatiles to the renormalized metatiles. So that means we do have to modify the map buffer for that purpose. So let's get rid of this. So basically what we need to do is This is map lookup. And this is and I realize that this is potentially the same value. I realize this is the same value as the palette that we're storing, but that might change at some point, right? We might decide that the palette values are going to be normalized or consolidated or optimized, whatever you whatever terminology you want to use, so that, let's say we have some tiles that have similar some meta tiles that use similar colors, we can tell the asset tool that they should share their palettes, and then the way we do this will be different. There will be some sort of way of looking up the palette value. And so then this is correct, but this is wrong. If we assume, or it would be correct in this case to have map lookup work this way, but then map palette wouldn't work this way anymore. So that's why I'm doing it separately, even though right now it's going to be the same thing for both sets of 4 bytes, because eventually that won't be the case. And I know that won't be the case. I might as well do it correctly now. Sometimes you know you're going to change it, so you're better off. So we'll do our map lookup, and then probably want to say max map meta tiles, or let's say max NES map meta tiles. And I know that that's not defined. Let's go fix that. So yeah, so we're good there. Now the only other thing we need to do is now we need to remap those values. So let's do this. If this is equal to 0, and we're going to change this a little bit. Count is less than max NES map meta tiles. So let's get rid of this. So now we're just going to iterate over the entire size of the map. And then what do we need to do? You know what we'll do? So we're going to cheat a little bit. I'm going to use Lookup Table. So Lookup Table is being used to determine if we had used that value for the palette, or if we had looked at that particular meta tile value for the palette calculation already, and we were just checking to see if it was 0. Because 0 is no meta tile. So what I'm doing is I'm putting the palette count into that value, so that when we go through the process of remapping the entire map buffer, we can just use Lookup Table as our reverse lookup, essentially, because now that will have, for the index of the meta tile, the palette value that we need, which is what we want for when we're rewriting this, essentially. So let me think about, this should be less than the palette count. And I guess for every one we say map buffer p is equal to lookup table map buffer p. The only thing is, do I want to do that directly in the map buffer, or do I want to do that? I guess it's okay to do it in there under the condition that when we're done, what I should do is I should reset all this so it doesn't try and use that information, right? Because what it's doing right now is it's looking at the width and the height and seeing that they're set, and then trying to load the map based on that. We shouldn't be trying to use that, especially if we're remapping everything. It's not going to be right. So, all right, so that's that. I assume that that looks like it's going to work. So let's take a look here. Let's see what happens when we come into here. So export. So I've got map lookup, map palette, lookup table. And so now we're going to iterate through the entire map. And we've got a value here. So map buffer p is 1. So lookup table 1 will now get you can't do that because, all right, so slight wrinkle in my plan. Palette count can be 0, so we'll do +1, and then this will be -1. Let me just put a comment here because I'm inevitably going to forget this and then be like, why did I do that? That looks dumb, and then break this. Increment the value by 1 so that we can still use this as a flag above. Decrement this value because if it's set to a value, it will be the correct value +1, and this is actually only true if equals 0. So if it's 0, it stays 0. Otherwise, it is the value -1. All right, so let's take a look at that again. Let's export. So let's go. So that's that, and then map palette count is 1. That's not right. Is it? Oh yeah, actually, I guess. So the value is 1. Maybe I don't need to subtract it because yeah, I guess I don't need to do this. Well, wait. Yes, I do need to do that. but I don't need to do that. Just get rid of that comment. Let's see, so that stayed as 1, which is right. Three becomes 2. Okay, that looks like that's working. So map palette, zero. So it's 1, 3, 2, 0 because we only use 4 palettes. We have 3 meta tiles, so there are only 3 palettes used. And then map lookup is those values. So map buffer, where it would have been 3, would now say 2. And that looks like that's what happened. Although the 0, that's weird. Before we write anything, I want to go back and look. I think I have it off by 1 here somewhere. Yeah, so those 0 values should stay 0, right? Lookup table 0. Oh, you know what? The problem is this is 1 for 0. And so when you look up, okay, let me fix this. This should be that, because lookup table 0 would have the value of 1 in it, which means it would go to 0. If you have the value 1 written in, that's going to go into position 1. Okay, so that's the problem, is that it's actually should be that. So the value of map buffer P didn't change. Map palette. Map buffer P is that. Oh, this, yeah, that's fine. Map palette. Yep. Okay, that looks right now. You can do multiple. Where's the other? I want another memory window, please. Window. Where the hell is it? I know there's a keyboard shortcut. I just don't ever remember what it is. Can I do a split? Can. All right. Map. So this is map buffer. So we hit the 3, which now becomes 2. And then 1 stays 1, and then 3 becomes 2 again. As long as 0 stays 0, That looks right. So we've remapped things in there. And then we have our map palette, which has the right values. We have our map lookup, which has the right values. So 0, yeah. And then we have our buffer, which has the right values. So we write that out. That should not have the black there. So why is that doing that? Hey, Midnight's SD Suki, thanks for watching the old streams. Hopefully they're helpful. I know they're long, but it's kind of the point is to show what actually goes into making an NES game when you're learning it and don't know what you're doing. All right, so just want to make sure that it doesn't display the background. Yeah, okay, cool. So that's what I wanted. All right, so now let's go to the let's get the level file. Where is it? So before we do anything else, let's just let's skip an extra 4 rows here. Because we have, or extra 4 bytes, I should say. Because of the extra palette stuff that comes after it. So we were figuring out where we want to start, but sprite mem needs to be adjusted accordingly. So we add a temp. Can we just add 4 to temp first? That should be, I think that'll be safe to do. Can we just be lazy about that and do that way? Oh, wait a minute. I'm already adding 4 here. Cool, so then I'll just make it 8. Because it's the 4 palette bytes and the 4 lookups. But obviously this isn't going to be exactly right. Now we're going to get the wrong tiles because now it's not a one-to-one mapping. Though that actually looks remarkably close. Although to be fair, I think part of that is because 2 of the tiles are both just solid colors. So once we get the palettes in place, it may turn out that they're not loaded properly. But anyway, all right, so that's good. That's working. All right, so let's load those 4 bytes into metatile table. So load a. So we'll kind of do the same thing here. What we'll do is we'll load a sprite mem. Well, so then we can go back to 4 here. Load a sprite mem, clear carry, add carry 4, store a sprite mem, and then load y0. Well, maybe we don't even need to do that. I keep changing my mind on how I want to do that. We can, instead of doing that, just because, yeah, we don't have to do that. What we can do is do this. Load a sprite mem y. And then we just want to do store a. Oh, well, so that's the problem with doing it that way. Because I want to use y to store into our metatile table. Do we need to do that? Maybe we just store the address and use 2 bytes instead. If we did that, let's see, if we did that, it's technically slower to do the lookups because they're in, it's an absolute read versus a read at the 0 page, or the first 200, you know, that can do the shorter lookup because the address is within the 255 first bytes there. And if we're going to do it often, it makes sense to, all right, let's do that. I mean, we can always change it. It's not a big deal. Load a sprite mem, clear carry, add carry 4, store a sprite mem. So we're going to load that and then store it in, I keep forgetting what I called it, metatile table y. So that gives us the ability to do that quickly, and then increment y, compare y to 4, branch not equal to lookup loop. Right, so that's that. And then we only need to increment this by 4 because we've already incremented it by 4 over here, so we've already skipped the palette. And then we have the max rows already, and we do the calculations. Let's see how that all looks, shall we? Nope. All right, so I obviously messed something up there. That's weird. It seemed like it should have worked. Source view, restart. So there's load level. To make sure that we're getting the values we expect to get. So here is our, I'm almost willing to guess what probably happened, but not quite yet. Let's see. So load a sprite mem. No, that's not, it wasn't what I thought. I thought maybe we carried in the add. Store a sprite mem. Sprite mem is now E8B. So metatile table has nothing in it right now, and it is at what address? It is at 78. 78 is there. So we're going to load that one and that gets stored. 78. Okay. should have stored it. Why didn't it store it? Why is... Oh, yeah, because I didn't initialize Y like I should have. That'll do it. Load Y with 0. Gotta remember to initialize things. Load A. Okay, start. Sprite mem is 1. The memory again. Go to 78. Y is 0 now, so Untitled Table is at 78. A was 1. It's the right thing, right? Untitled Table. Okay. Untitled Table. It sees it. No, dummy. Wow. Okay. Sorry, that was just me doing something dumb. Using the address that's in Untitled Table to write to the address in memory using Y as the offset instead of using instead of doing what I should have done, which means that we could do what I thought we were going to do and then said, no, we won't do it that way. So, sorry. So what I should have done, so what I should do is this and load x 0, y can stay where it is, compare that to 8. You don't need to do this add carry 4, and then we do 8-byte increment here, 4 bytes for the palette indices and 4 bytes for the meta-tile lookup. Sorry. You know, it's weird. I feel like when I'm not doing this over the weekend, it seems different than when I'm not doing this during the week. Like, because I'm not necessarily thinking about this or programming as much over the weekend versus, well, it's my dryer. Sorry for the little background music. I feel like it's because I'm not thinking about this during the weekend as much as I am during the week, and so I kind of, you know, other things push it off the proverbial stack of things that I'm thinking of. Oh, of course, I'm not incrementing x now. That's a whole different problem. I'll fix that in a second here. So I end up kind of clearing my plate for Monday. Now, in some ways that's good because then I'm thinking about the problem a little bit differently than I would have if I was just continuing on with it. But in other ways, it's frustrating because then I make silly mistakes because I forget exactly how things work, which is why I've tried to start adding more comments, because otherwise I definitely forget. Okay, good. So we got 1, 3, and 2 as our lookups, which is what you would expect. And then that's working. And then all we need to do now that we have that lookup, all right, so if you search code on Bing, you could run it. Well, that's kind of cool. I didn't know that. I'll have to try that. I don't use Bing. I just out of habit use Google. So let's see. So when we are loading our meta tiles, we're going to get our value, and then what we need to do is transfer A to X and then load a yeah, this is actually pretty cool because it's pretty simple to do. Meta tile table X, and then that's our actual value that we want, and we'll check that in a second. Do I need... Oh, cool. And then X is reset after that, so we don't have to even clear that out. All right. I'm actually not crazy with the name of this, just because it's similar to metatile buffer. Let me do this metatile lookup. And then one of these days we'll actually have real graphics. Okay, what happens if the lookup failed to work properly? Let's take a look at why. The thing that I really like about this is that it's so much easier to do debugging because I can search by my labels and my actual code. This is so freaking good. Alright, so next meta tile does that. Let's take a look. Let's restart the game, run it, get into this. I don't need to do that. That looked good. So ROMY gives us 1, so we're going to transfer that into X, and then metatile lookup. If we go to 78, 1 is actually 3. Is that what you're saying? 1 is 3. Source code, please. Metatile lookup X1. That seems... Hey, Dasani Fresh. Yeah, they're all posted on YouTube. So on the feed information, I post them. But if you go to, if you look me up here, I've got all the previous 43 streams I've done posted on YouTube. Alright, so I feel like I messed up this re-indexing somehow. So 0 would have stayed 0, and then the first tile that we encountered in the asset tool was tile 1, and tile 1 should have gotten remapped to 1, except that tile 1 is... Wait a minute. That's not exactly right, because all right, so the problem is that because metatile 0 is no metatile, and that's how it is, but I'm not storing it that way in this. This is actually, this should be this, And then this actually needs to be one larger because it's got to hold. I may have to rethink the way I'm computing all of this, but I think that will fix it. I think that's what the issue was, that it's just because the palettes are 0 indexed, but the meta tiles are sort of 1 indexed. There is a meta tile 0, but it's not one of the ones that we actually care about, so it doesn't need to be able to do a lookup. Actually, so that makes me think of another problem, is the fact that we did not do the lookup in load level, which would have clued us into the fact that we messed this up from the very beginning. So let's do this. So let's take, where's the value that it's, so it's looking up sprite mem y, transfer a to x. And then load a meta tile lookup. Oops, it should just be meta tile lookup x. If we looked. So this will now be similarly wrong, but that's okay, because it will be consistent at least. Okay, so it's actually not too bad. It's just off by 1. So the, let's see, not the script window. Yeah, so this is 6502 assembly language. The NES ran a custom version of essentially a 6502 processor. It wasn't the original MOS 6502. It was one that was custom manufactured by I believe Ricoh was the company that made it for Nintendo. So CC65 compiles for any 6502 processor essentially, and that's what we're using to build for the NES. Alright, so this loading is now off by 1. Why the hell is that the case? Let me look at the PPU here. It's just off by 1 meta tile. What's the deal? 8, do that lookup, and then add 8 to it. Is that? Oh, it's not 8 now, it's 9. That's why it's off by 1. This is not 9. This is 0 through 4. Oh, this is throwing everything off. This is 5 because meta tile 0 is unused. And then we have to add 9 here. I think that'll fix it. There we go. So that is now, that's looking correct. The palettes are obviously still wrong, but that's okay. We knew that that was going to be the case. If we look at, I feel like I should change the map again so it's a little more obvious where we're at, so that we know that things are loaded properly. I know I did this before and then I changed things because we were looking at the colors, but let's do that just for the sake of making sure that we actually are feeling 100% confident in the way that the map is loading, right? So let's pause this for a second. So let's start like this. Let's just, if you watch previous streams, you know I did this because it just makes it obvious if you have gaps or something in the map when you're loading it. It always helps to have predictable data when you're doing something new or rewriting, because then it's very easy to spot the obvious problems. Now, sometimes you have edge cases that you don't plan for, and then it goes sideways, but that's okay. At least for some sanity, you have something that is a little bit straightforward that you can visually see, especially with this kind of stuff. You'll be able to see pretty quick if things have gone wrong. And I'm switching sides just to make sure that, you know, we don't have anything that for some reason would affect one row from one side but not another, or if something's inverted, or who knows, you know. You just try some different permutations. And like I said, eventually we'll have some real artwork and we can start putting together some real levels and actually, you know, make a game and not a tech demo. But that's the hard part, right? The tech stuff is actually pretty straightforward. And when you're working with the NES, what's nice about it is that it's pretty hard to mess up. Like, I mean, you know, you mess up, right? And there are technical limitations that make it harder to program for. But when it's not working, it's pretty much because you didn't do it right. It's not like when you're working on modern software and it's like, is it me or is it the software? It worked yesterday, but then I updated and now it's not working. Oh look, they made breaking changes. That's modern software when you're working, especially on the web. Anytime anything changes, you run the risk of something breaking, and that's why nobody wants to do updates, because once it works, it becomes very fragile. Yeah, if you guys haven't watched or even know what I'm talking about, there's a great talk that Jonathan Blow just recently did. If you don't know who he is, he wrote Braid and The Witness. You should know who he is, but if you don't, he made those two games, and he gave this talk recently on the programming language he's writing and why he's writing it and the current state of software. And it's a good talk. You should check it out. It was under Game Lab 2018. It should be easy to find. Definitely worth watching. Even if you don't agree with what he says, it's worth looking at what he's doing and why he's doing it to understand his perspective on why things are broken. Now, personally, I actually think he's right. Not that my opinion matters all that much to what he's doing or anything, but, you know, having worked in software for a while, see, look right away. Now the question is, was the map? Oh, it's the map. Okay, so the map had that. I was too busy talking and I messed up my pattern, but that's okay. That's why we look at these things. But having worked in software for a while, I've seen the shift in quality and the way software is developed And you know, not to sound too much like a crotchety old man telling you to get off my lawn, but it really is different compared to how it used to be. People used to be really genuinely afraid of, for example, breaking interfaces or APIs, and now nobody cares. There are regular releases to things that they just break. Who cares, right? Nobody thinks about all the countless man hours of time that developers spend dealing with these things, and trudging through all the nonsense that's involved in doing modern development for the sake of, you know, not having to do garbage collection or whatever, memory management or whatever argument you want to make for modern programming languages. All right, so that's all looking good now. So our lookup is working good, and our loading is working correctly. So now the hard part is we now have to do our, or it's not even that hard actually, because now the kind of cool part is the attribute memory is going to match. The attribute memory is going to match our tile values 1-to-1. So let's see. So right now, this was setting up the memory to go to, yeah, so this was, this code here, gotta be agile. Yes, good yet. I mean, there's, let me talk about that in a second, and then I will, let me get this going, and then I'll talk about that. Let's see. So y, this can actually be 0, I think, right? Because y is going to be incrementing through the tiles, and then we just want to reload those values. Sort of. We don't want just the y value. We want, let's see, we want the y value, and then we want to arithmetic shift left 4 times, and then we want to store that into temp, and then we want to load this, and then we want to do an OR with temp, and then we want to store that in attribute buffer. Let's see if that works properly for. So basically what we're doing is we're taking the tile value, which is just a single, you know, it's just the direct tile value. We've made y 0 because we've finished loading the actual tiles, and now we're loading the attributes. But as you'll recall, we have to take the now we have to take the sprite, the meta tile value from this location at sprite mem. We want to shift it into the upper nibble of the byte, the upper 4 bits, and then we want to store that away temporarily. We'll get the same. Oh, okay, so then we want to increment y for the next meta tile, and then we want to OR the value of temp, which was that shifted one, and that should be right, I think. I mean, we'll see. Without thinking about it too much, that should be right, or it'll be close, or not at all. So let's see. check tile Y, branch unequal load tiles. We get setter 23C0 for the attributes. Y is 0 here. Do we modify? We incremented, let's see. So we incremented this, so sprite mem does start at the right position now. So that's okay. This is that, that's all good. We'll debug that in a second. So I just hope I can use Jai before 2020. Yeah, I mean, it seems like he's using it to actually make a game. For those of you who don't know, Jai, J-A-I, is Jonathan Blow's programming language that he's working on. It seems like it'll be done sooner than later. I mean, he's making a game with it, but the whole agile thing that's good yet brought up. I mean, there's some value to that. I mean, when you're on a large team, I've worked on large teams where, you know, you spend a lot of time working on a feature for a product because, well, you know, that's what you need to do. That's what people are looking for. Am I using temp somewhere else? No. You know, and you get a whole bunch of features and you work on them over 18 months or 2 years or longer, right? And then you deliver it, and by that time the industry has changed, and so you know, you're always playing catch up, and Agile really helps with that because the whole organization, your whole company, your whole development team is focused on delivering features as quickly as possible in a reasonably sane way, if everybody's actually on board with it and doing your scrum calls and your sprint reviews. So I don't really have any issue with that. I mean, it's just trying to do development in a way that acknowledges that things are constantly changing, which you know, that's the reality. So instead of trying to plan for a product release, you know, when you're building a product over 2 years and you're saying 2 years before it's due to be released, you're going to lock the features in with designs and stuff like that. It's way more realistic to plan it, you know, 1 week at a time. And yeah, you plan for whatever the, you know, major release milestone is, but you do it in a way where if you have to change directions because you have a major enhancement that you have to add that you didn't originally anticipate, it doesn't send everybody into a tizzy. All right, so we stored this in temp. We increased y. We have the value of 1, and then we have 1, 1. And then, why do I feel like I'm doing this wrong? Because I am. Because it's not just 2 values, it's 4 values, isn't it? Right? It's 4 by 4. Top left, top right. Right. Okay. My apologies. I'm talking and trying to do this at the same time, and it's not exactly working out the way I want. So store that, do this, increment that, then we'll shift this 4 times instead of 6, and then we'll do that, and then we'll store that in temp, and then we'll increment y again, and then we'll do this twice, And then we'll do that. And then we'll store it back in temp. And then the last one is the simplest. Okay, so let's see. And then it's, except the order is all screwed up, of course. Let's make sure we get, so it's bottom right is 6. So this is going to be the top left, which is actually 0 shifts. Man, attribute memory sucks. It is the I think the bane of Nintendo NES developers' existence. Let's see, like, make sure we got this right here. So this is top left, and then top right. Oh, this is really crappy. All right, so we're gonna shift this to, and then what we have to do, this is so, oh, I didn't even think about this. That's annoying. So, yeah, so what I'm kind of laughing at, because I didn't think about this, is that it's not really linear like the map is. So what I need to do, I mean, it's not a problem, it's just annoying. So we got that, and then what we'll do is transfer A to Y, transfer Y to A, and then what we need to do is we need to add 8 to it, essentially, because we need to get to the next line. So let's see, so we get the top left, the top right, bottom left, which is shifted by 4, and then the bottom right, which is well, so this is where that's just a macro for the number of repeats so that I don't have to write it out so much. For 2, I don't mind, but okay, so that's 1, 2. We're going to get, then transfer A to Y. We don't have to do that increment here. And then we increment that. And we shift that, and then we store it, and then what? And then we say transfer Y to A. And then we just subtract 6, or what? Where are we at? No, we subtract 8. Set carry, subtract 8, because we're now at the next one. We keep doing that until we get to the end of the line. Now, when we get to the end of the line, we'll have wrapped around to the next one, but it's already been stored. I actually think what we need to do, we need to do 2 loops. One where we load the attribute memory, and then another where we just dump it into the PPU, only because they're 2 sort of distinct operations, and trying to mix them is going to be a pain. basically what we do is this, and then we say, here we're done loading the tiles, and we load x0, and then we just do a repeat 64 of load a attribute buffer x store a 2007, and that'll write the attribute buffer out. We're doing that instead of a loop because it'll be more efficient to unroll that. Let's see. So not crazy with the way that this looks. I'm a little worried that this is going to add too much overhead to our, well, I mean, if we do this and only write the one row of attribute buffer information on the screen lookup or the screen update, that might be okay. We'll see. So let's see. So if we do that, I guess what we need to do, let's see. Sort of having a hard time conceptualizing what we're doing here. So we have, let's say, we have the 2 rows of meta tiles, right? And so what we're doing is we're saying it's this. Oh, wait a minute. No. Dumb. Sorry. Dumb. We can still keep this way, but I forgot. The meta tiles. The whole reason we're doing the meta tiles that size is to make this as simple as possible. And then I screwed it up. All right. All right. Yeah, so we load that value into A, and then, sorry guys, that was stupid. What's the easiest way to do this? So I just want to put, basically I just want to put the value into every 2-bit section. I'm trying to think of what's going to be the easiest way to do that. Let me get rid of this here. So that value then needs to be yeah, you said 2 years is nuts, but that practice, that whole idea of software development that way, that was the standard thing. 2, 3, 4, 5, 6, 7. You know, when I started, that was how we did it. We wrote up specs and design docs and all this other crap, and then, you know, and then you delivered a product after 2 years or whatever it was, after a year, and you were like, okay, what's next? Shift 2. Okay, that's what we need to do. So what we need to do is load it, and then Shift 2, and then do an OR, and then Shift 2, another OR, and Shift 2, and then another or, and we're done, and we store that, and then we increment x, and then we compare x to 64, which is 40 hex, and then I don't care about that. And then we branch, if not equal to next attribute. And then otherwise we jump to done loading tiles and we load the whole buffer right then and there. Let's see how this goes. This should be interesting. The first, let's see, this should be breakpoints here that don't make sense anymore. The first, okay, so it's not, okay, it's not terrible. It initialized the attribute memory with something, so that's not terrible. That's could have been worse. One and then shift and then or that and then shift and then or that and then shift and then or that. Okay, that's cool. And then x is 0. That is correct in that we are now, if we look at that in binary, 55 hex is 01010101, which means it's telling it to use it's telling it to use palette 1, which if we look at the palette viewer is this palette, which is, that's what's wrong. It should be palette 0. And the reason that's that, okay, that makes sense. So, and then that's the only reason that's the case is because, can you do that? No, I didn't think so. Can you do that? No. The reason that's the case is because metatile 1 is using palette 0, not palette 1, because palette 0, metatile 0 doesn't, we don't care about what palette is we want to have for, really, you can't do, I just want to decrement A. Okay, let's do this. Oh, damn it, I can't. I need X. Let's do this. Store it in temp, and then decrement it, and then load it back, and then we just use temp. There you go. Okay. So restart that and start and it's fine. Let's see how this goes. Yeah. All right, so the first screen is looking good, I think. Let's restart this for a second here. Let's take a look at this. Almost. It's almost. Well, actually, you know, I can never tell because Messon's palette is a little bit different. Let's take a look at the palette viewer. Now that should definitely be like a navy blue sort of color. So this isn't right. It's using this purple. So let's take a look at. Oh, well. Yeah, that helps, right? You got to increment your index there. So it's just reloading the same palette every time. Let's see if that fixes it. That'd be cool if that was the problem. Yeah, that was it. All right. Cool. So nice. So that's it for the first screen. And then we basically have to do the same thing when we load a new so what we need to do here is essentially the same thing. Okay, so we've got our meta tile stuff working here, and then what we do is, I don't think we're using temp for anything in here. So okay, so same thing. So we say load a, row_mem, y, store it into temp, decrement temp, store load a with temp, and then ASL or a temp, ASL or a temp. So let's see, that's that, and then we just need to know, oh actually, well, it's a little more complicated than that, right? Because we have to know if we are in split mode or not. All right, that's not too bad though. So let's move this to the bottom, because when we're done, we'll do our increment. All right. So let's see. So we're gonna look if we've, yeah, we don't need to do this every time anyway. So for meta tile flag, okay, so if we've actually loaded a new row of meta tiles, then what we need to do is we need to figure out, are we in split mode or are we in full update mode? Now, if we're in split mode, we're loading, I gotta think about that. So when we're loading, hey Vestrek, when we're loading the screen, we're loading name table. We're loading this bottom half here, and the bottom half is actually the upper bits. Right, the bottom is the upper bits. So when we're in split mode, we need to do, so at the very least, what we need to do is we need to do this. And then we need to say, okay, are we in split mode or not? Because if we're in split mode, branch of not equal to done with attributes, not quite. But if we're in split mode, then we are, what we have to do is we have to look up the position in our attribute buffer and and I think that's just the X value, right? What is the value? We have attribute index, that's what it is. All right, so let me think about that. If we're in split mode, we have that value all good, and we need to load the value from so hold on, let me bring back some of this code that I nixed. we do need it. We need the attribute index here. And keep that in temp2 for now. We may be able to make that a little bit better, but all right, so then we have our attribute index, and then we are load a row mem, load our attribute value packed for, okay, so we don't need that anymore. That's essentially in, oh, that's essentially in temp. So let's do that. Load a temp, and it with the attribute mode, store it in temp2. This might actually work out better than I thought, because we may be able to reuse most of this. So then, and the attribute buffer, yeah, and then use temp2 with that. That's good. And then store that back, and then look and see if it's a split. And if it's not a split, then we, yeah, this is very good, because I think this is going to work out mostly the same now. So we subtract 8, and then we wrap it, transfer A to X, and then we load temp, because that has our value. Branch if carry is set from the, yeah, and then that's the only reason we have to do that is if we wrapped around, then we have to flip some stuff around because of the way that the, if you'll remember from the other streams, the way that the attribute tables work, they're a little messed up at the top of the screen. But okay, so we'll load that, and then and it, and or that against temp2. That done with attributes, skip mask change. I think this can all stay the same now. And then we don't need this extra Y increment. Holy cow, that would be cool if that fixed that. Although, I don't remember if we're copying. I don't think we're copying the attribute memory still. Well, we might be, based on the way that that's. Let's see. It's not 100%. This is obviously not good. So this is just me seeing where we're at here before I think a wrap for the night. I want to see if we get. Oops, bumping the microphone here. Okay, so we're corrupting memory somehow, or palettes, or most likely it's something with the way. Let's see if we can squeeze it in here under time. We're obviously we're not getting this in properly during the updates, so let's see how bad this is. Event viewer. All right, let's see. Switch to source view. That's my drawing code. I want to. It's amazing. It even understands the differences in the files. So cool. so this is the code here. Basically, I want to add these breakpoints, but I just want them to show up in the event viewer. I don't want to actually break on execution. Yeah, I mean we're definitely let's do this. Let's take out the updates to the attribute buffer completely, and let's just see what running this code looks like. Because I'm wondering if that's just inefficient. Okay, so that seems to be okay in terms of just updating the attribute buffer, assuming that that's actually working properly, which is a big assumption, but can't. Let's see. Can't have everything. What is the address? Attribute buffer is 0. So it's right at the beginning of our memory, and we're going to shrink this down to 8 so that it's literally showing us what the attributes for the screen are. That looks close. I mean, if it's not 100% right, it's probably close. The FF value seems wrong because that we wouldn't have any palettes. Well, I guess we do have palette 3. Well, no, we don't have anything that should be using palette 3, right? Because palette 3, or at least not yet. See, palette 3, yeah, we're not using this at all. I mean, if we make this like sort of, so it's some of the things have gotten set to that. Let me do this. Yeah, so nothing should actually be using that palette right now, or at all. So there's a bug in the way that this is working. So this is loading value, storing it, decrementing by 1. So let's see if the tile is 0. It's using palette 1. That's fine. And then it's loading it back into A, and then it's doing the shifts like it was before. Right? It's doing 2, and then loading it, ORing it, and then doing 2 more, and then ORing it and doing 2 more, and then ORing it, and then it's storing it so that we have that. So then attribute index gets loaded. Let's make sure that it being initialized properly. That is that right? This might, let's see. Yeah, that's okay. So that's that, and the split mode would be, it would be set to split initially, so it would load the value from temp, which would have all the attribute values, and then it would say, okay, do an AND of the attribute mode, and the attribute mode being split would give you 0. It's 0F. So we would take the value, whatever it is, and you'd zero out the top bits, and then let's see, and then it's transferring that to X. Oh, okay, right. Sorry, we didn't. I'm looking at the wrong thing. I'm not paying attention. So, right. So it gets the index, puts that in X. It loads the value, does the AND. So whatever the value is, we're getting just the lower 4 bits, and then we're storing that in temp2, and then we're loading the attribute mode, and we're getting the inverse. And then we're ending that against the attribute buffer at that position, and then doing the OR of temp2. So let's see. So if the value was 5.5, or actually it would be, would it be 5.5? No, it would be AA. And then we're doing an AND against F. We get A. And then we're storing that A off somewhere. And then we're getting the attribute buffer value. You know, maybe we'll just do this in the debugger because I don't foresee being able to do this easily. Where's the debugger? I'm going to open it back up. Okay. Okay, so I'll change this to actually be something I want to see. All right, so temp has the value 0 because we want palette 0. Attribute index is 38. And the mode is 0F, which is split mode. So we do the AND on that, and we get 0. And then we're storing that in temp2, which now has 0. And then we're going to load the mode again, and we're going to invert the bits. And then we are getting the value from attribute buffer, which is in fact 0. But was it 0 or did it get updated? It should have been. Let's take a look at the map. Yeah, okay, so come on. That doesn't look right. Let's do this. Let's go back to the debugger and look at it after we load the memory, or load the level, I should say. Let's take a look at the attribute buffer at the end of that, right before we jump back from the subroutine. So where's the memory? So this is 38. So it's 0, 55, 55, 55, 55, 55, 55, 0. And if I were to look at this, I guess that's this, but that doesn't seem... Oh, it's this. What is that it got? Is that just garbage that it loaded at the end of the map? I guess so. I mean, it looks, you know, that's right. The palette. Okay, and actually that's cool because it shows, so when I mouse over the attribute value, if you look over here, the attribute data is shown for the tile that I'm mousing over. So that's perfect. That actually matches up to the memory over here. And then the next one would be all zeros because it's those. That's fine. And then the next one is 55 all 55 0 and then F. Why is it F? That is not supposed to be. Oh, you know why? Because it's subtracting the 1. That's why. So that's what's messing up everything, I think. Compare temp to FF. Branch not equal to skip fix, skip tile fix. I don't know. You can do anonymous labels. Not feeling super comfortable about that. So where you basically just kind of reference the next one. But anyway, so increment temp back to 0 essentially, and then load a temp. That should fix that particular issue. So where is the actual emulator here? Okay, F5 start. All right, so we go back to our memory. We still have the FF. Why? Load a temp compare to FF. Branch not equal to skip tile fix. Load a 0 0. Oh, I didn't do a store. I did another load. Anyway, I don't have to do the increment. Actually, I can do both. There, I'll do a load and an increment, and then we're good. Okay, so let's look at our memory again. Crap, why is... You're gonna make me debug this part now? Fine. What am I messing up? One, subtract. It's all fine. 1, 1, 1. Okay, so that's 0. We store A, and then we decrement temp, and it becomes FF, and then we load it, and then what? Where is my... Did it not load those changes? Skip tile fix. Next meta tile. Load new row. I'm in... Oh. Well... Helps if you're in the right place, I guess, right? I'm not in the load level code. I'm in the code later on that does the same thing. So decrement temp, load a temp, compare to increment temp, load a 0. Doing an extra load for nothing there. All right, so the only other thing I need to check is load level, I think, is in its own scope, so it shouldn't be. Yeah, okay, so that label has no impact on that. All right, that's what I thought. I wanted to confirm before we had all sorts of crazy behavior because we were jumping into the game code accidentally. So let's see, load, store, decrement, load. Yeah, let's put the breakpoint here and look for for a to be 0. Store it, decrement it, load it, compare, branch not equal, increment, and load that, and then, okay, so that fixes that, and then I want that breakpoint there, and then if we look at this, that's much better. We don't get those crazy FF attribute values, and let's continue on. Okay, and so now we shouldn't be seeing odd updates based on increment attribute table being wrong. So let's see. So we are now going to be looking at this. Well, I guess I don't know that I want to look at that necessarily. I just want to see what happens. Let's see. We should see. That seems like that's good. I mean, the problem is ultimately still that, you know, we're not updating the attribute table. So we won't know until we do that part. And obviously we can't do this whole big update like I want to. Does that mess anything up? Let's see if just even... So even just doing that... Really? I'm not even storing... I'm just updating the... It's just because of where I'm doing that operation. Hey, Lag Shield, this is 6502 assembly language for the original Nintendo. You know, the 1986 one. Let's see. So the problem looks like that I am updating when we hit the new meta tile row. I'm updating outside of the v blank here. And the question becomes now, what can we do? What can we do to make this a little bit more efficient to make that fit? And that'll probably have to be a question for next stream. Because, I mean, we obviously can't remove the the sprite stuff. We need those to get updated. It seems like the code for dealing with the meta tiles itself is okay. Just seems like the color, the attribute table update here is not working. I mean, we're still getting a little bit of jumpy behavior because of that code, I would imagine. Not that it's adding that many cycles, but I guess it's adding enough. I don't know. We're gonna have to do some intensive looking. I mean, it's not as bad as I thought it might be with the lookups that we've changed, and the good news is that it looks like the attribute table updates that we're doing in memory are okay. So, you know, there's at least that, but I mean, there's a decent amount of code that's going on dealing with the way that we're doing the scrolling and going into each meta tile row, and certainly enough quite a bit with the way that we're handling all of the stuff related to the stuff. Sorry, I'm thinking about this as I'm trying to explain the stuff that we're doing related to the way that this is being handled for the attributes. I'm actually thinking we don't even need to do this. Load a temp, and the value only needs to be a value from 0 to 3. So that eliminates the branch. Not that that's killing us necessarily, but branches are not cheap. So do the same thing here. Pretty sure I got that right. Need a value that's not 0. Oh, actually, damn it, no, that's not going to work, because we're not trying to make that wrap around to 3. We're just saying we don't want it. Maybe there's a clever way to do that. If we have the value, FF and hex, right? It's essentially all the bits are set. And if we do an AND of 3, we get the value of 3 because the first 3 bits are set, but what we really want is yeah, that's not going to work. All right, anyway, that was just a failed attempt at optimizing out that branch, but we'll have to see. We'll have to see what we can do to make that a little bit faster. What we can start doing is looking at the way that this is all being handled, and we can hopefully use the debugger and the event mode. What I'm thinking is, you know, we can add some events. Like, I'm thinking we do this. We say, okay, where is it? So process scrolling. So like literally right here, we have our first breakpoint, and then until we're basically done. See, this is the other thing. We're doing our scroll here, where if we do it too late, we're gonna end up with a problem, right? Because if we're doing it too late, then it's already past the point at which we should be scrolling to get the the status bar drawn because we've taken too long doing this work, and then as a result we mess up the status bar, which is where we get some of that other weird artifacting that we're seeing. So what I want to do is just turn all of these off and look at the breakpoints and kind of see visually where they fall. Except I don't want that. So you can see there's a pretty big gap, and that gap widens and varies pretty wildly. So what we need to do is we need to make it more consistent and kind of shorten that gap. Like if we were, sorry, I'm scrolling through like crazy here. If we were to just, for argument's sake here, if we get rid of this for a second, don't worry, we'll bring it back. And restart this, and then we've got to remove these breakpoints because they no longer make any sense. And we go to this point, and we'll, let's see, we're here, so we mark this breakpoint, and then we go to where we were done with the PPU updates, which is here. Again, we mark that breakpoint, and then we look at what that looks like. That's still, that's still pretty large. That's still a pretty large gap. So that makes me think that while this is working okay, that's actually the bulk of the work. The bulk of the work is not these meta tile updates that we're doing here, which, you know, I mean, they're not, it's not nothing, but we're doing at least as much work, maybe more, with the way that we're handling the meta tile row updates. So we need to figure out how to make that a little bit more efficient too. So that'll be for next time. But made some good progress, got that code reworked, got the asset tool generating what it needed to, so that's good. A little bit of confusion on the way that the indexing worked, but that's all right, we got that fixed. So cool, that worked out pretty well. I got a little distracted talking about things that had nothing to do with NES programming. But as always, if you have questions, I'm on Twitter at Clearvis. I'm posting these recordings on YouTube. I will put it into, I'll put it in Twitch on the feed. I will also post the link on Twitter. I'm also on Nintendo Age, in the forums, and the actually more so in the Discord than the forums, but I'm there, and we'll resume Thursday, 9 p.m. Eastern. Thanks for watching, and I'll see you next time.